Welcome back to mean reversion algorithmic trading in Python. Before we start, I actually have posted the complete Jupyter notebook in the blog section of intrendias.com. So here you could download the complete mean reversion strategy, and it goes into detail about what mean reversion is and why we're doing it, key components and stuff like that. So if you're very busy and you really want the complete Jupyter notebook on hand immediately, then check out intrendias.com blogs section. Besides that, we are going to get straight into it. So we're going to use the average true range, which is a technical analysis indicator that measures market volatility, and it's commonly used to make stop loss levels in trading. So what I would like to do is first create a custom function that allows us to calculate this very measure, and I'm going to call it create ATR so that it's easy to understand. We're going to pass in a data frame, and I'm going to give it the argument of data frame, and then we're going to give it a default period value of 5. The period basically meaning how many simple moving averages should the window be for the SMA. Now that we have that, we are going to look through the true range formula. Essentially, we want to do 3 calculations, find the difference between high and low, find the difference between high and previous close, and then the difference between low and previous. And whichever is the maximum value, we are going to attribute that value to equal true range. So from our data frame, we will be using Yahoo Finance to gather this data, which is going to be in the form of OHLC, which is open, close, high, and low. So we're going to create a variable called high, and we're going to assume that the data frame that we will be passing in will have a column named high. We're going to do the very same thing for the low. We're going to derive the value for the previous close as well. And in the Python data frame from Yahoo Finance, we're going to see a close column, but we want the previous close, not the current day close. So we're going to say shift 1, and that's going to provide us the previous day's close. And then the true value is going to be stored in a numpy array, and we're going to call the maximum argument. This is going to allow us to find which value of the 3 are considered the largest. So now we're going to do the arithmetic of high and low, and then another numpy. We're going to do the absolute value of high minus previous close, and then another numpy absolute value of the low minus the previous close. So this line here represents high minus low, numpy high previous close, and then low minus previous close. So this is going to find the maximum that we see here. The numpy maximum reduce function is the way to find element y's maximum across multiple arrays. So the 3 calculations are, the ones here, and the result is going to be a single array which is named tr values, where the element represents maximum potential for price movement, which is ATR. So this is going to return TR values. Next, since now that we have this TR, we could perform the sum of TR over a specified period. And in our case, the default is period 5. So we're going to now say ATR is equal to pandas series and TR values. We're going to perform a rolling. This is the SMA situation where we're going to have a moving window that crawls through that time series and performs a mean for that given period. So since our period is 5, it's going to take into consideration 5 days, assuming that the data we derive or fetch from Yahoo Finance is in the 1 day interval. So the PD.series TR values, this piece right here, is essentially converting the once numpy array into a panda series, which is a one-dimensional labeled array that can hold any data type. In our case, it's going to be numeric float values, most likely. TR value was calculated here, so we can drop it into this argument for the series. And then rolling mean, simple moving average. So now that we have that, we can go in and retrieve the most recent ATR value, and we could perform this by doing the iloc -1. So it's going to reference the very last row, and the data frame, we can give it a brand new column so that we could store it for later use if necessary. And then the data frame we can create another column called stop loss, and this is going to be a constant line through the entire data frame, and we can say close dot iloc -1, and now we're going to reference the brand new ATR that we just created. ATR dot iloc -1 is multiplied by 2. So this section here is more arbitrary. You could have a more conservative stop loss and not multiply it by anything. You can multiply it by itself, or you could have a lot more swing, so you could do 3 or 4, whichever you feel comfortable with. I personally did 2 here to reference the ATR so that the close price is greater than this stop loss, since we're doing a minus here. And then that'll provide us a constant stop loss line. And then for the returning, I could just say return data frame, and that will be our create ATR function. So in the previous episode, we performed some arithmetic for the get quote and the percent change, but we still have not brought in open close values yet. So I would actually like to perform that now so that we can test out our brand new create ATR so that we can ensure that it's correct. So I'm going to copy and paste this line here. This data frame Yahoo Finance download is using the Yahoo Finance library to gather some data for us. So here I'm going to say, for example, Apple, and we can have a start date of the past date, and then an end date, which is the current date. These values I'm getting from these custom variables that we created previously, where the current date is today's date and the past date is 2 years ago, which results in 2023 and 2021. So that works. So we're going to throw those into the download function, which is straight from the Yahoo Finance library. And then if I did that, it does not work. Let's see where I went. See where I went wrong here. Okay, yeah. So just gonna put these in parentheses, ensure that that multiplies. And then Yahoo Finance is not defined because I did not go through and run through all these lines as previously. The download got an unexpected keyword argument ticker. Yeah, that's right. These are not in the documentation. So calling it end date would be incorrect. I think interval is the right argument, but I'm just not gonna. I think this should work here. Let's try it. Yep. Okay. So my issue was in the documentation. Um, the argument here was not ticker and it wasn't start date. Um, but I had the order of arguments correct. It was a matter of using the correct argument name. Here we have the ticker named Apple and it downloaded successfully. We have open, high, low, close, adjusted close, volume, dividends, stock splits, all that good stuff. And it starts in 2021, like we said for the past date, and then the current date being 2023, December 11th. So that all checks out. So it's good. So now that we made our create ATR, notice how we have open, high, low, close, blah, 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 stock splits. So what this function is going to do is create an ATR column and a constant stop loss column as well. So now that we have a df, we can say df is equal to create ATR, and we're going to pass it the brand new df, which we've created here, and the period of 5. Since this is actually an argument that we already passed in the previous function, we can actually forego it and it'll automatically assume we mean period 5. So now I'm going to run this and hit enter, and now automatically we have the ATR, which is calculated, and then a stop loss derived from close minus ATR times 2. So now we have a stop loss in case the trade goes south and we can minimize our losses. So it's always good to have. Now that we finished ATR, we could move into EMA and Bollinger Band, which is the backbone of this algorithm. To start off, we are going to create a function that creates a new column for the EMA calculation. So I'm going to call this EMA, and we're going to pass in the data frame, the pandas data frame that we just created up above. The field argument, this is going to be a string that represents the brand new column name. And then finally the period, which is an integer representing the number of periods for the EMA calculation. So first off, we're going to have a one line of code that's going to say EMA is equal to the data frame. We're going to perform the F string so that the new column name is going to be dynamic. So we're going to stuff field in there. Next, we're going to have .ewm. This is the exponential moving window object, and this is going to allow us to do the calculation. The span is going to be the number of periods that our function here takes into consideration. We're going to pass that argument in, and then the adjust false is going to be the next item that we type in. The adjust false ensures that the exponential decay is calculated without adjusting for bias at the beginning of the time series. And then at the very end of the day, we're going to perform a mean, calculates the mean of the exponential moving window, taking higher weight for most recent days. And then this function is just going to return that single line of code that we just wrote. And the returning statement is a calculated EMA pandas series. So now that we have that function created, we could do a result example just to make sure that the function does indeed work. We're going to pass in the data frame that we made with Apple. The field name is going to be EMA 20. Let's try that. And then the period is going to be 20. And then we could take this name. This is going to actually be what column should we be referencing. So within the data frame column, we're going to reference the close price to perform the exponential moving window on to then calculate the EMA. So close would be the correct answer here. And then result EMA that calculates the exponential moving average EMA 20. So this works out perfect, so that's good. First, for Bollinger Bands, we are going to create a new function and call it create EMA and Bollinger Bands. We're going to take into consideration the data frame again and the period 20. Period 20. We're going to do 20 as the default argument. You could choose whichever value. And then we're going to say the data frame, we're going to conduct a f string again, exponential period, which is going to keep this new field name dynamic as possible so that if we do conduct multiple EMA and Bollinger Bands, then the columns will always have a distinct value based on the window size. We're going to have the EMA function referenced again within this function so that instead of having to reference this, then do Bollinger Bands, we could just create all three of them in one go. So we're going to say EMA, data frame, close, period, right? We're going to pass in the data frame, which is here, and then the period default 20 goes into this argument as well. So instead of having to write all of this multiple times when creating multiple EMAs, we could just say this and save a lot of time. So functions are definitely helpful for repetitive coding. So now that we have the EMA, we could start calculating the standard deviation down below. So we're going to say data frame, f string to keep the columns unique in terms of names. We're going to say standard dev period is equal to the data frame f string once again, the exponential period, and that way this will always be equal to this, so we're always referencing the same thing. So from the statistics library that we downloaded imported in the first episode, we're going to use this argument here, which is standard deviation. Then we can calculate the upper and lower Bollinger bands, because we need both the standard deviation and the middle band. Essentially, the middle band is the EMA that we're using. So we're going to say data frame F string again, upper band, and then the period. So we got that is equal to the data frame of F string. Actually, I need that on the outside. Exponential period. And we're going to do an addition. So we are taking the exponential moving average value in this instance of the data frame, adding 1. So this 1 here is the n value of the standard deviation. Usually, Bollinger bands are the value of 2 times standard deviation. So you could choose whichever value you'd like. For this example, we're going to do 1 times this standard deviation. So honestly, we actually really don't need this when calculating, since it's just 1 times itself. So we're going to go ahead and get rid of that actually. Standard dev, F string standard dev, and the period argument once again. And we're going to close that out. So essentially for the lower band, you're going to do the exact same thing. However, we will minus the standard deviation out so that you get a upper and lower band. And that should be everything. So what you could actually do is, let's say, add a brand new argument and say n equals 2, which is part of your upper band and lower band equation up here. And then you could actually say something like n times. So maybe on a whim in the future, you'd like to say, oh, instead of minusing out 1 standard deviation, this stock has a lot more volatility, so I'd rather multiply it by 2 standard deviations, stuff like that. So you could edit this however you please. For the sake of the video, I would just keep it at 1 standard deviation and see how it goes. So then I can say return the data frame, because this function is going to create new columns and add it into our existing Yahoo Finance data frame. This data frame is going to return the EMA, standard deviation, upper and lower bounds of the desired period. So now that we have that, we can say create EMA and Bollinger bands and say data frame. I already have a data frame active up here, which is Apple's data. So the data frame of the period, and I'm going to say 128. And then the ATR and stop loss is also still here, but notice how we now have the exponential 128, standard deviation 128, upper band 128, and lower band 128. So that way I could run this again and say, hey, actually calculate the 20 period. So I could just say that, and then it'll just keep adding on to the existing data frame. So here are my exponential 128s, and here's my exponential brand new period 20 stuff. So all that is there. So that works, so that is perfect. All right. So we just went through how to calculate the EMA and Bollinger Band technical analysis section, and we also successfully obtained data from Yahoo Finance using the Yahoo Finance library download function, and we also created our very own ATR function that returns the stop loss line for our stock. Um, you could also do this for cryptos and indexes, what have you. So we're making good strides. So next, in the next episode, we're going to do the back testing algorithm. Obviously, with any trading algorithm, you want to be able to keep track of how well the algorithm is performing, and you would have some sort of benchmark. So at least for Intrendias.com, for example, you go to Intrendia's terminal and you have access to volume breakout and the original Mia algorithm. For example, on Apple, the Mia algorithm does pretty well on Apple, and Trendia's is up 113% compared to Apple's performance of 51%. So the bought and held strategy, which is called Apple Performance, is going to be your benchmark to compare whether or not the trading algorithm performs a lot better. Or if it performs worse, then perhaps the buy and sell signals don't have any validity. So we're going to keep working through the code, and sooner or later you'll have buy sell signals and a back test that looks similar to the ones we see here. So very exciting stuff. And of course, to close out the video, if you want the full code, you could go to the algorithmic trading in Python code mean reversion strategy in the blog post. This is all free. You could download it and you'll have access to the complete mean reversion strategy. So I hope you enjoy the episode, the series so far for this coding algorithmic trading course. If you do, hit the like and subscribe. Comment down below what could be done better, what you currently like. Love the feedback. Also, if there's any other algorithms or trading strategies out there that you'd like to see me cover in code, perhaps you have a strategy and you want to codify it and maybe it could become a series or what have you. Love to hear your thoughts on that. So thank you for coding along with me and watching Intrendias and visiting Intrendias.com. Appreciate you guys, and I will see you guys in the next one.